So on our review packet, make sure you're looking at the ones that are circled. Those are the day one topics. So way back when we used to give you guys polynomials, this particular one is in factored form. I want to ask you a few questions about it. So it's number 4 on the review packet. I want to know the exact value for f of 0. This should be a really easy question, and yes, you get the calculator the whole time during your testing for finals. What are you supposed to do with 0?
Plug it in for x.
For x, yes. All your x's become zeros. So, again, I'm not so good at the mental math, so I probably would double check everything I do on a calculator tomorrow. So 0 plus -2 times 0 plus 5 times 0 minus 3. Don't forget to raise it to that part to the third power. That factor does have multiplicity on it. Type, because this is a weird number and I don't know it off the top of my head.
170.
Yes. Did you mentally do that? Good for you. Did you? Very good. -10 times -27. Yeah, I guess it's not as hard as I thought it was. Nice job.
Maybe thinking about like everything going into it.
I know.
I mean,
I get panicky on tests. You know the kid I keep warning you about that does all the cute little mistakes and gets everything wrong? Because, yeah, that's me. I'm that kid. All right, find the...
no other.
There's, yes. All my stories are about me. The local maximum is not a difficult question. In fact, I ask my Algebra 2 kids this question all the time, so we got to put a little twist on it. Can y'all get this typed into Y1 on your calculator? And just for funsies, start in the standard window, because that's where your calculator is going to be when you start your test tomorrow. So, you know, do a zoom 6 just to look at the standard window, so we're all looking at the same thing. Oh, I closed down. You can do second plus sign. So in the standard window, which is where our calculators will begin, this particular polynomial looks a bit like this. So what's the challenge when I say, please find your maximum? You can't see it. So PreCalc, we got to fix our window. Which part should I be fixing here? I need to go higher, so the Y maximum has to be way bigger. And it might take you a while to figure out how big. Just go to 1,000. It's pretty big. Yeah. Can you see the maximum now? You should be able to see it. But to actually find it, you're going to make your calculator do that part, right? So go to the Calc menu, second trace. Choose wisely. You're finding a maximum value. And then either do some hopping or scrolling. I'm going to go and hop over to -4. That would be before the maximum. And then you can either scroll or hop to the right of the maximum. I'm going to hop to -1.
Whoa.
And then your maximum ordered pair, please give me an appropriate answer. Now the directions say to round to the nearest hundredth. So if you wrote 3.00 and 864.00, you are incredibly accurate and good at reading instructions. Good job. You can just write 3,864. I'm okay with that. However, if the answer comes out icky, like 2.718394, blah, blah, you better learn how to round to the appropriate place, PreCalc. I'm going to count you wrong this time. On your final, it's pretty mean. How do you can... I didn't zoom out. I just made the Y max go to 1,000. Right, so that's a pixelation issue. The repeating 9s, or in Adam's case, the repeating 0s, just let's call a 3 a 3. It's 3. Yeah. I didn't write that down, though, so I forgot what it was already. Was it -3.8? Thank you. And then I want to know intervals for where it's increasing. Now, your graph looked a little weird. It looked like this, kind of. And let's talk about what's happening down here. So over here where it does this weird flat thing, this is where the solution of x equals 3 shows up with a multiplicity of 3 times. And we didn't often have odd multiplicity for PreCalc. What happens when you have odd multiplicity is the function comes down and kind of like hangs out at the x-axis for a while before it commits and goes through the x-axis. So there are no maximums nor minimums in this location. So this is the only turning point. And back when we did the graph analysis, it's been a few months, but back when we did this, we would have you guys highlight the x values of the turning points. So that reminded you to only give me x intervals on this next question. So this ordered pair here, remember, was at x equals -3. Who cares how high up it was? And this is the part of the roller coaster where it's increasing. the rest of the roller coaster is decreasing all the way through to infinity. So the interval for which your function is increasing is from negative infinity and then up to -3 with a parenthesis. Always use parentheses on those intervals.
Oh, what?
Mm-hmm.
Oh, it's because it's not still increasing at that.
Right. In calc, you'll talk about the derivatives and things about the functions, and it essentially is a slope question. So the slope at the top of the roller coaster is 0.
So if it has slope, then it would have...
If it has a positive slope, it's increasing. If it has negative slope, it's decreasing.
Right. And so if it had slope, you would put a bracket on it, obviously, so it doesn't.
Those will never have brackets because your endpoints are either going to be at a turning point or approaching infinity. Does that make sense? None at all? Okay. All right. Skip. There we go. There's the next one. All right. First question. Zeros. Please include multiplicity. Don't forget this little guy here. He's a factor. So if you were to set that factor equal to 0, you would get a 0 at 0. Now, if you wrote multiplicity 1 here, that's incredibly thorough of you. Thank you. You don't have to. I assume you mean multiplicity 1 if you just write of 0 one time. How about this factor? That's a 0 at 2. And again, if you wrote multiplicity 1, you're incredibly thorough. Thank you.
-8 3 times.
All right, and then Daniel says -8 is the weird one. That one shows up 3 times because of the third power. So this one I definitely need to see a note about multiplicity 3. Mrs. Hofbauer likes her kids to write the multiplicities out even though they're ones, because if you were to add up all these multiplicities, you get the degree of your function. So this function is a degree 5. 3, 1, 1 is 5. So when I graph it on the calculator, more than likely, because no one likes to think real hard on a test, you're going to see a function that does this on the ends.
Yeah.
Because the next question is end behavior. Now, we have tested you on this without a calculator. Tomorrow is not one of those moments, so you get your calculator. Let's talk about end behavior. You do need to know the template. So f of x approaches something. Usually you guys go left first, so as x approaches negative infinity. And then f of x approaches something else as x goes to the right. Just don't mess with the order that you usually do this in, and then I think you'll be fine. So if we look at the left side first, x goes to negative infinity means look at the left side. According to my calculator or my brain, my function is heading down. We call that negative infinity. Good. And then as x goes to positive infinity, that's a fancy way of saying the right side, my function is going up. Remaindeer. You just made a little winter Christmas joke. That's adorable. I'm going to give you author credit on that one. You can keep that one. Ignore your remaindeer. Oh. Alright, use the appropriate method of your choice. I want you to divide these two polynomials. Okay, show of hands. Who wants a good old long division question? Yeah! Me too. I love long division. Who wants synthetic division?
Yes.
Majority rules. Synthetic division it is. That was a rough moment for you. Now, we're dividing by the polynomial of x plus 4, which is a very basic polynomial, which means you can use synthetic division. So, -4 is what goes in the box. Good, the solution to that factor. Now, the only thing you gotta be a little careful about, sometimes I get tricky, and I put missing coefficients in. Does this one have any missing coefficients? Oh, thank goodness. Alright, 1, -6, 4, and -2. Now, is this one of those questions where we're supposed to get 0 remainder? Not necessarily. So sometimes you guys panic when you don't get a 0 remainder. This is not one of those questions. However, it does say to ignore the remainder. So that's refreshing. They don't even want me to write the remainder. All right, here we go. 1 times -4, -4. Add them up. You get -10. Then you get a 40, 44, -176. Although I don't really know why I keep working because they did tell me to ignore my remainder. So you can just stop, yes. It's almost like an oblique asymptote question. Like I just want the body, the quotient of the division question. So now all I need from you is, do you know how to interpret those coefficients? Remember, you started with an x to the third, and you divided by an x, so this is an x squared, yep. So 1x squared minus 10x plus 44. Alrighty. So far so good? What a relaxing test you're going to take tomorrow. Aren't you glad we quizzed you to death on all this? You're welcome. Oh, this should be the 2 easiest points on your whole test. Actually, I think it's only 1 point, but you better get it right. Number of possible real zeros. How do you get that number, kiddo? Because the degree of your polynomial is 4, yes. Number of possible turning points. Yes, so the degree minus 1, better known as 3. Please get that one right. You can do n minus 1.
Okay, I was just curious if that was what you
I usually just write degree out. Alright, watch the technical wording on each question. I want very specific things on very specific answers. I want you to take your polynomial, and I want you to write it in factored form. So it's still going to be equivalent to f of x, but y'all got to factor this with me. So first I look for a common factor. Is there a common factor? I hope so.
1. Negative. X squared.
X squared, yeah. If you took out an x squared, you still are left with x squared minus 4x minus 5. I believe you can factor some more. So don't do that cute, adorable thing where you get your signs backwards, though. Multiplies to negative 5, so how about x minus 5 and x plus 1? Yeah. Would that add up to negative 4? Cool, cool. All right, there's your factored form of your polynomial. There's not a whole lot of time on this test for you to be checking things over on your calculator, but if you get to the end of the hour and you're like, man, I always screw that question up, investigate how you could check your work, whether it be through graphing or whatever. But wait till the end of your test before you do that. There's no extra time on this test, guys. So bell rings, you out of here. We're done. Yeah, I got to solve it first. No, good question. So the real zeros, which there is a 0 right here at 0. If you wrote multiplicity 2, you're just very extra, and I love it. You don't need to do that. This guy has a 0 at 5, and this guy has a 0 at negative 1. You do not have to include multiplicity on that particular question. All right, who's next? For not including multiplicity? Oh, I won't. Okay. You're just going to, for the rest of your life, put down multiplicity? Yes. Just so everyone knows what's going on? I mean, if you're doing a problem where you're finding solutions to a polynomial, multiplicity is always an important clue. Okay. Will it happen in your future much? No. All right, list all possible candidates. So this has no involvement with your calculator whatsoever, guys, other than computation. What should I put down in my answer blank so I don't forget it, though? Yes, I'm going to put down plus and minus symbol because I forget it. So now I look at my constant, and I write down all the factors of my constant, which are 1 and 2 and 4. Now I write down all the factors of my leading coefficient, which are 1 and 3. And now I separate these into what I'm really looking at. So first I take the 1, 2, and 4, and I divide it by the first factor of 1, which is not very exciting. That gives me a 1, 2, and 4. And now I'm going to take the 1, 2, and 4 and divide it by the 3. So that would be a 1/3, a 2/3, and a 4/3. So that question doesn't necessarily touch the calculator, but the next one does. So it's the same polynomial. I need you guys to graph it. And knowing that these are your only possible, usable rational zeros, I want you to tell me if you can figure out where all the zeros are. But the fun part comes in your defending of your solution. Like, how do you explain it? You might want to go back to the standard viewing window once you get this guy typed into Y1. I'm pretty sure you guys can quickly see negative 2 and 2 as 2 zeros. And I think with a little calculator work, and also using the list of possibles that we had here, I think if you check negative 1/3, you'll see that that is also a 0. The way you can check it is you can just hit trace and then type negative 1/3 and see if it comes out to a 0. I also just did this problem with first hour, so I know that's the answer. That's nice. But here's the fun. How are you going to confirm all these roots for me?
Plug them in.
Meaning what? You'll draw it for me? There are multiple ways for you to confirm. Knowing you guys and knowing what works best for you, synthetic division, successive synthetic divisions is probably the best way for you guys to confirm. So what I would do is I would successively synthetically divide as many of these as you want. And you can take it all the way down to the final lead coefficient. I'll show you what that looks like. So take your first 0 that you know worked. Like you know one of them worked, right? What was it? -2 totally worked. Now if I use synthetic division here, you should, in this case, this is where you should get a remainder of what? If this is a factor, this is a solution, we better get a remainder of 0. Because if I don't, that means no, this actually was not a 0 of this poly. All right, let's see. So this is a 3. Yes. And we do get a 0 on the remainder. Okay, so this is where you have a decision to make. This is a choose your own adventure math problem. Ready for this? You could continue on and synthetically divide the next 2 zeros. Or you could stop here because you're at a quadratic and you can factor. So you want me to show you both methods and you can decide from there whether you'd like one or the other? Just shut up and factor. Well, I'll do both. But if you go over here and you go to factor it, let's see here. How about a -2 and a +1? Would that work? That's going to allow you to write your factors that you just got. But where's my third factor? The one that we used to divide, right? So that factor becomes an x + 2. So at this point, you could be done with the question. Except you have to go now and explain. We'll get to that question in a second. Now those of you who are like, I don't know if I like that method, let me show you another method. So you saw on your calculator other zeros that you were pretty sure worked, and you checked them on your calculator. Well, if you continued on with successive divisions, so we just did the -2, so now let's do it again with the 2. Watch what happens. According to us, this is a 0, so what should I get in my remainder right here? I should get a 0. Let's see if it works out. Oh, looky there, it totally worked out. So now we checked that one. You can check a fraction. Look what happens when you check this fraction. You bring down the 3, and you get a -1. And what do you get right here? 0. So that was you checking the last one. Now, who is this? That's my leading coefficient. So if you took synthetic division all the way down to the leading coefficient, then you would have a 3 as a leading coefficient, and then you just go back and you write these all as factors. So x + 1/3, x - 2, and x + 2. Who's right? They're both right. I like them both. Yes, Daniel, go ahead.
So, I did -1/3 before I did the 2.
Yes.
Will that mess me up?
No.
Because it messed me up.
It messed you up. Okay. So right away you did -1/3?
No, I went like the -2.
The second step?
was
Okay.
you, and then the second
Okay.
step.
So 3 times -1/3 would be -1.
Yeah.
So you have -6.
Yep.
-6.
Wait, oh, I have 6.
Yeah.
That's my
So
issue.
with no mistakes, no, it shouldn't mess you up. All right, so you have to kind of make a decision, guys. Like, which method did you prefer? Do you like to just knock it down to a quadratic and factor it? Do you like to take it on home all the way as far as you can in synthetic divisions? You decide, because your next step is now you have to justify and explain how you confirm that each of these are roots. I think the easiest way to confirm that they're roots is just when I use synthetic division, my remainder came out to
0.
That's a great explanation for all those. Yep. So you can't, yes. So the first one you confirmed, right, by synthetic division. So you still should mention that. So when I did synthetic division with my 0 at -2, I got a remainder of 0, which means it is a solution. Then you could continue on and say, I factored the quadratic, and here's the rest of my factors. That's fine. It's however you choose to explain it. Your work and your explanation should match. I just want to make sure that whichever way you're choosing, this coefficient of 3 has to be in your problem at this final part. A lot of kids do all this great work and they lose their leading coefficients somewhere out there. Don't do that. Alright, so I haven't actually explained anything, but maybe I should. So I used my calc and saw the 3 zeros. I think I spelled zeros wrong. Then I did, the fancy phrase is successive synthetic divisions and got remainders of 0. Yes.
I just said when using synthetic division, my remainder came out to 0.
A remainder? Did you write remainder?
I did.
Fantastic.
Would you accept that as an answer?
Yes, I would kind of like you to mention what you did way up at the top, though. Like I used my calculator and saw that I had a 0 at -2, so that's why I chose that. No, you're going to totally mention that on the test. Okay, so you're going to have a formula sheet that helps you out with the rationals like we always have. So the vertical asymptotes and horizontal asymptotes sheet, you'll have that. I'll give you a new copy of it when we test. Find the equations of all vertical asymptotes. So I know I'm supposed to factor everything right away. The numerator doesn't factor, but this denominator totally factors into x plus 1 times x minus 1. Ooh, that's ugly, sorry. So, off the top of your head, do you guys remember how we find vertical asymptotes? You set your denominator equal to 0, and you solve it. So there's not a ton of work on this one, guys. You're going to get x equals positive 1 and x equals negative 1. The important part is that you actually give me vertical asymptote equations. If you just write down positive and negative 1, you're wrong. I need the equation, x equals. Very good. This is still in that same section with the asymptotes. This one asks about end behavior. So end behavior is either a horizontal asymptote, which would only be a thing if you have a equal weight or a bottom heavy fraction, or an oblique asymptote. And oblique asymptotes would only occur if you have a top-heavy rational fraction. Which one do we have? Top-heavy. So if you have a top-heavy rational fraction, that means you have to find your oblique asymptote. Do you remember how we find it? No, that's for equal weight. Division. You got to go through and divide it. The quotient, the result is of your division question, ignoring any remainder, that is the equation for your oblique asymptote, which is our end behavior in this question. So I leave it up to you guys. Long division or synthetic division? Synthetic. That was a quick synthetic. All right. So -3 is what we put in the box. Oh, careful. Good call. There's a 0 because there's a missing x term. Sneaky, sneaky, huh? All right. Little synthetic division. Double checking that I can add. I'm not even going to finish this question, though. Why do I not need to take it all the way down to the remainder? It's not part of my... Yes, it's not part of the asymptote. So these coefficients become this poly, so 4x squared minus 15x plus 45. And if this is my answer here, my teacher's going to take off a point because that is not an equation. Y equals would be fine. I got you, though. Yeah, it is the same thing. You wouldn't be wrong with good f of x. I would accept that. Now, I need some words from you. Use your big kid words, guys. Explain using the end behavior rules. So, no, none of that. I want to know your thought process as to why you even did this work. So, because our... Whoa, I can't spell. Okay. Going to try an eraser. Nope, that's not an eraser. Because our rational function was, and I'm going to put this in quotations because it's not the official phrase. Ugh, my gosh. Apparently handwriting is not a thing. All right, top heavy. The function has an oblique asymptote. Which is found, right, by dividing. You don't have to go into more detail than that. However, what if you had an equal weight fraction? It would look very similar, right? You'd say because our rational function was equal weight, the function has a horizontal asymptote at the lead coefficient ratio. Or if it was bottom heavy, you'd say because our rational function was bottom heavy, the function has a horizontal asymptote at y equals 0. Okay, so using big kid words. And you better spell asymptote right. I'm kidding, I don't really care.
You don't find what asymptote?
Try.
Maybe my handwriting sucks enough to work.
I might just assume that you know how to spell it without really digging into it. Okay, this is still on part 1. These questions, now this is a friend of ours. This is just a simple quadratic, guys. So you're welcome to use your calculator, but I can tell pretty quickly because it's in factored form that you're going to have, oops, that's not what I wanted. You're going to have over here at -5 and then over here at 1/2. Those are the two x-intercepts for this quadratic.
Yes.
But you have a calculator, so if you're not sure about that, that's fine. So talk to me about what we could do, and I think those of you who did this on your test when we did test this section, this is 2.6, you had lots of luck when you wrote the sign chart. So at -5, things switch, and then at 1/2, things switch. So before -5, your function is up here above the x-axis, so we would refer to that as positive. Between -5 and 1/2, your function is hanging below the x-axis, so that would be a negative output.
Yeah.
And then after 1/2, we got positive again. So read me the question. What does it want?
It wants things, intervals.
It does, but it says greater than or equal to 0. We're going to have to use brackets on the on the intercepts right there, but not on the infinities. So the reason I like the sign chart is if you can kind of match up the colors in this case to your brain, like you see the intervals staring at you right now. So from -infinity to -5 with a bracket. Union, good. Yep, very good. And feel free to bust out whatever colors you want to bust out on this test, guys. It's not like a don't write on the test moment. You write all over that test. Because I probably will too. Yeah. Actually, I don't think I'm giving a lot of feedback on this test because it's not like you can do anything with it. So it's just going to be some colorful mean lady slashes. Wrong. Smiley face, something like that. All right. Oh, that was the same question. Okay. They're back. It's just been like 3 days. They're back. All right, so we have matrix A, which is a 4x5. You have matrix B, which is a 5x1. And my first question is, can we multiply them?
Yes.
Yes. The answer is yes. Because why is the answer yes? The innards, yes. That's a yes. Now, some of you got a little confused on Friday. 5x5 is not the resulting matrix.
No. 4x1.
4x1 is the resulting matrix. There we go.
So it's down 4 over 1, right?
4 vertical, yes, rows. Yes, 4 rows, 1 column. Thank you. Yes, I said the wrong thing. I think you guys did fantastic on this question. A few of you just got some sloppy algebra going. But this is very similar to what you're going to see in your test tomorrow. It's a little simpler than the one you guys had on the test Friday. So you're going to want to substitute. Wouldn't it be nice and easy to solve and plug in for x? That'd be beautiful. So x equals y plus 6. So like right here, this becomes y plus 6 quantity squared. Which most of us remember that means we have to FOIL. FOIL that baby out, you're going to get y squared plus 12x plus 36. This, oh, it's a y. Thank you. And then plus 2y squared equals 27 is the rest of the equation. We are shaping up to get a quadratic. In all likelihood, it's going to have two answers, and we will work with them. All right, so we end up with 3y squared plus 12y, and then if I subtract the 27 over, it's a plus 9. And then Daniel's looking ahead and says this quadratic is lovely, but you can divide everything by a 3. Because it's a coefficient in an equation, it can actually take a hike and get out of the problem. So we have a much nicer quadratic to solve. And we get two viable solutions for y. And as promised, this is factorable. If you do all this work and you get some crazy thing, something's wrong. You get two possibilities for y. So don't fail me now, guys. You're almost there. On your answer blank, give me two ordered pairs and write down the two options for y, but make sure they're in the y position. Now we go back to our formula for x. X is found by taking y plus 6. So this plus 6 would be a 3, and this plus 6 would be a 5. That's very similar to what you're going to see tomorrow. A pretty basic quadratic equation pops up, very factorable. Depending on how you solved it, you either get two x's or two y's, so you're going to get two ordered pairs at the end. You guys did fantastic on the test on Friday, so, like, good news. The whole back page of your post-test tomorrow is this. What were you supposed to do with this inventory matrix? Yes, you're supposed to add them together and then get your result. We're a little short on time, so I'm going to assume you all can add. All right, scalar multiple. I want to mark up by a 12% markup factor. So that means you want to keep all of the price, so 100% of it, plus another 12%. So I need to figure out 112% scalar factor. What would that look like? 1.12. Good. And then your updated pricing matrix. You don't have to use an actual matrix, guys. Most people just take all of these and multiply them by 1.12 on their home screen, which is probably faster. It is money, though. I didn't mark you down that time, but I'm going to have to mark you down on this one if you can't round properly. Money comes out to 3.67, 5.60, 1.67, and 10.07. All right, this one should be nice and easy, but there's a typo. I think I forgot to warn you guys. This guy right here is supposed to be a W. Can you fix that on yours? Make sure that's a W. And then all I need from you is the augmented matrix. Y'all did lovely on the test on this question on Friday, so I'm going to skip that one. You did a good job of setting this one up, and then some of you kind of faltered with, like, how do I do this on my calculator? Because you got two methods confused. So you're supposed to take the coefficients to write it as a matrix equation. You take the coefficients of the body. And then the next matrix would be the variables in that order, so x, y, and z. And then equals the solutions matrix in that order, 10, 8, and 23. So depending on what method you wanted to solve this one with, some of you entered these as separate matrices. You called this matrix A and this matrix B. And if you did that, then you had to apply the inverse matrix of A and multiply it by B. That totally works. But I frankly feel it is much simpler to just do RREF on the augment. So if you entered the entire thing as a 3x4, I don't know why I made such a huge matrix, sorry. Lots of space. I think some of you with the options, you never actually practiced one of the options, and therefore you got confused with which option to use. Because you remembered there was two options, and one of them included an inverse, and one of them didn't. I think RREF is easier. I'm just going to flat out say it. There, I said it. RREF, easier. Do what you want, though. I don't know. You get 4, 1, negative 3. I'm a calculator.
Oh.
What do I look like? A calculator? Okay, now if I can say one question I had to mark off too many times in this class, it would be this question. Thank you. This has many solutions. I see that. Many solutions. That zero thing. But what I need from you is the ordered triple. You can't just say many solutions and say I'm done. So this statement right here, this says x plus 4z equals negative 9, or whatever formula you were thinking. These, I think they're always x, y, and z, but whatever you want. It's the very end.
The very end?
Yeah.
Oh, not on the test. The test is right there at the top.
Oh, on the test. I'm sorry. And then y plus 4z. No, not 4. 7z. See, that's that cute thing I'm always talking about. Like, you write down the wrong number. So cute. Okay, here's where some of you were like, this is where it failed. What I need from you is to first recognize that z is just going to be called z. That's what I get from this last statement. Okay, z can be z. Now you need to rewrite x's and y's in terms of z. That's the use a single variable thing. So rewrite x equation so it says x equals. So that would say x equals negative 4z minus 9. This is what you put in place of x. And this guy says y equals, subtracted this over, so negative 7z plus 3. This is what you put in place of y. That's what I needed from y'all.
I did that.
Okay, let me check. All right. Study, study. That's happening tomorrow. You must finish within the class time, okay?